serial isomerism we can divide two types. One it is optical isomerism and the another one it is geometrical isomerism. So before that, what is optical isomerism? Optical isomerism, which the compounds it is rotated, the sample it is rotated through the plane polarized light, which is producing the, when we are rotating either right side rotation or left side rotation, it is right side means extrorotatory and left side means evorotatory. So what is before that? What is plane polarized light? Okay, what is plane polarized light? When it is comparing to the ordinary light it is when it is giving the directions in the different directions. Plane polarized light will give the rotation only the single direction. Okay. Example, this is ordinary light. Okay. Plane polarized light. Okay. So the next geometrical isomerism. Geometrical isomerism means it is having the two isomers, cis form and trans form. Okay, cis form and trans form. For example, cis form we have we can take one example for lactic acid. Okay, the cis form means the compounds which is having the chiral. Generally, compounds having the chiral achiral carbon atom. Chiral means it is having the carbon which is attached to the different atoms. Okay, with the four atoms. See, for example, lactic acid. Lactic acid is having COOH, OH, H, COOH. Lactic acid which is having the, for example, we can take the tartaric acid also. So this is cis form. Trans form means the hydrogen and hydroxyl group will come opposite side. Trans form. This is trans form. Okay. Why this trans and this when we are rotating the compound which the plane polarized light is rotating the, what do you mean by extro and levo? The compounds which is having, which contains hydroxyl group on the chiral carbon atom. Chiral, this is also chiral, this is also chiral. Chiral means it is optically active compound, it is not superimposable to mirror image of each other. It is also known as chiral center, stereo center. Here we see carbon is having the COH, OH, H, different carbon atom. That is only chiral center. So chiral, it is known as chiral carbon atom. Chiral compound is optically active compound. Optically active means it will rotate. It is also called as enantiomers. Enantiomers which contains optically active also, optically inactive also. Okay, that is achiral compound. Achiral compounds it is having the, they do not have carbon. It is around the different atoms. Example, achiral carbon atom, hydrogen, hydrogen, maybe COOH, COOH. This is achiral. It is not having the stereo center or chiral center. Because of that it is achiral carbon atom. Achiral means it is optically inactive. It is not superimposable. It is having the superimposable of mirror image of each other. Superimposable means, for example, non-superimposable. So the same compound we are taking here, H. So optically inactive compound it is having the optically inactive compound it is having the plane of symmetry, that is axis of symmetry. You will be having that optically inactive compound achiral. So we should not have plane of symmetry, axis of symmetry. That compound it is chiral carbon atom, optically active. Okay. Next. For example, how we can know that superimposable, non-superimposable. So the same, this is tartaric acid. So our hand, no, this is non-superimposable. Okay. So like that. So same tartaric acid. compounds we are taking and keeping. This one is attached like that. We are taking like this. This is non-superimposable mirror image. Okay. Superimposable mirror image means this one. Already said no. This C H C O H C O H. No compound. This transform, it is optically inactive superimposable mirror image. It will not divide two half when we are dividing planar with either parallel side or ups down. When it is we are dividing, it should not divide. That is only superimposable mirror image. For example, in a planar symmetry here you can divide. We are keeping this plane of symmetry. So both sides it is dividing the two equal halves. So it is superimposable or non-superimposable? It is superimposable or non-superimposable? It is optically. We should analyze as it is optically inactive or active? Inactive. Okay. So when we are, for example, 2 pi plus c. Example is. Lactic acid. Okay, here NH, COH, COH. This one we are substituting and changing. For example, okay, wow. So here COH, here COH, NH. This is one. Our we are taking one example generally. So COH, this is transform or cis form. This is transform. Okay. This is cis form. Okay. So we are dividing two equal halves. Yeah. Okay. This is also equal. This which one it will be a same like molecules. This is superimposable or non-superimposable? Which one is superimposable? Non-superimposable. This is non-superimposable. This is superimposable. Optically inactive, optically active. Okay, understood? When we are dividing this one, it is changing of sign. Both it is. For example, you understood no superimposable, non-superimposable. Our handle like this is non-superimposable. This is optically active chiral carbon. It is having the chiral center. Okay. Next, those. Okay. So what is meant by superimposable, non-superimposable? Tell me, Ajodika. Superimposable standard. Superimposable, non-superimposable. Superimposable optically inactive, active. Last year, superimposability is optically active or optically inactive. Superimposable. Optically inactive compounds. It is also known as achiral compounds. Example for achiral. Okay. Achiral it is not lactic acid. Lactic acid is chiral compound. Okay. Achiral it will be a please Okay, next. External. This side. Iron carbon atom is what? Anyone get? Anina? Iron carbon atom is optically active. It is non-superimposable. So exactly, iron carbon atom questions are coming means we have to say first the compound which contains the carbon atom. Around the atoms are 4 different groups. Okay, 4 different groups. That is example activities. Okay, the carbon atom which contains, okay, it is attached to the 4 different groups. This iron carbon atom. Iron means it is not attached to the carbon, particular carbon. For example, the already said no. COOH, H, COOH. So only H2, COOH. Only 2 groups are. This is achiral. Carbon which around the atoms are should be a different groups, 4 different groups. That is chiral. It is optically active. You do not have mirror image of each other. Okay. Achiral means the carbon which is not having the 4 different groups. Okay. Maybe 2 groups are club, 3 groups are club. Okay. So it is known as achiral. Achiral is optically inactive. For that example, isotartaric acid. Isotartaric acid. And also it is having the plane of symmetry. Glass siphon. What is plane of symmetry? Example, plane of symmetry. Plane of symmetry. In that it is comes under where optical activity. What do you mean by optically active compounds? What is optical activity? The compounds which is passed through the plane polarized light which produce the different rotation, right side and left side. It is optically active compounds and phenomena it is known as optical activity. There. That compounds it is known as optical isomerism. Okay. So compounds it is having the plane of symmetry means what? Plane of symmetry is there means it is optically active or optically inactive. Optically inactive system. Plane of symmetry is there, it is optically inactive compounds. Okay. Next, how we can know whether the plane of symmetry is there or not? When the compounds they are dividing the two equal parts, whether upside down or parallel side, it will be a divide. The